Started. My name is Edward Pretzel. I'm your host and your speaker today. This is a webinar where we will be talking about using cost models for inflation offset and effective negotiations. We will be focusing on castings and machining today, and we're offering a free trial analysis if anyone is interested. But I'm the founder and the president of Collaborative Supply Chains. We are a company dedicated to product costing and implementing cost models within supply chains. We have multiple recorded webinars that support this topic, and you can find those on our website, www.collaborativsupplychains.com. When you think about savings and cost management, really it's a two-step process. Step one is we have to find savings opportunities. And so we're very good at using cost modeling and cost engineering to be able to identify those opportunities. We cost at the same levels as manufacturers or suppliers, and that's very important for credibility. Credibility sets us up for step two, which is effective negotiations. And so we'll talk about that today. What is the strategy and the process for an effective negotiation using cost modeling and cost engineering? Our agenda today, I'll introduce myself and our company. We'll talk about the basics of product costing. We want to kind of level set on what is the basic formula for product costing. Number three, we will certainly talk about inflation offset. We will focus on castings and machining. We will use a recent real-world example. Number four, we'll talk about effective negotiations, what's important to set that up, and what are the common tactics that suppliers will use and how to manage through those tactics. Number five, we'll review very quickly just our free cost modeling trial analysis, and we'll take any questions. We ask that you please mute yourself. We want this to be interactive, so please ask questions. You can use your chat function, or you can speak. I will pause at the end of each slide to take those questions, and we'll take questions at the end of the presentation. Very quickly, I'll introduce myself. So I'm an industrial manufacturing engineer, went to school at the University of Michigan, and really have spent a career implementing lean manufacturing for General Motors and Toyota, and also implementing cost models within supply chains. And so I have launched and managed cost engineering programs for some of the world's largest suppliers in the automotive industry. Those include the Lear Corporation, that's the world's largest supplier of seating systems. They also do wire harnesses. TRW, which is now part of ZF, is the largest safety systems supplier, so airbags, braking, anti-rollover technology, seat belts. Dana is the world's largest supplier of driveline systems, so axles, transmissions, drive shafts. And so we started this company 6.5 years ago. It's called Collaborative Supply Chains. We have gone open book, and that's kind of our niche. We'll talk about the different types of cost models, but we have done what we call collaborative open book cost models, implemented about 3,000 of those over the past 25 years. We have analyzed approximately 250,000 parts. That's important because that's where we identify the savings and the waste and continuous improvement opportunities. We do speak at Michigan State University and Wayne State University as a guest speaker about this process in the supply chain management curriculum. So we're a company dedicated to the implementation of cost models. Most of our work is done with supply chain management organizations, where we proactively identify waste reduction opportunities and help supply chain management know what products should cost. We also support product engineering. We provide them the feedback with their designs, with the strong focus on DFM, design for manufacturing, to help product engineering make good business decisions right up front in the product development process. I do have to say, with all of the inflation, we have been very heavy with our customers in setting up processes to evaluate those, to identify improvement opportunities, and to help them offset some or all of the inflation and price increases. And then to the right, you'll see some of our bigger customers. In general, we transition companies from just typically managing costs through market pricing. Market pricing relies heavily on having options and competition. It requires less expertise, but the results are higher prices. So we help transition organizations to cost-based analysis where we focus on the cost drivers. We want a cost at the same level as a manufacturer. We can get very good at identifying cost improvements and support data-driven negotiations. The results are lower cost structures, typically in that 5 to 15% range. Although we started in automotive, our costing customers are across many different industries. The process of costing products is the same, although individual industries and even companies have their unique specifications and requirements, also volumes. And so we adapt to those, and we can really support any industry. We do a lot of costing in metals, so stampings, forgings, castings, powdered metals, machining, fabrications, both flat and tube. A lot of plastics and rubber. Also electrical and electromechanical, so connectors, terminals, wire harnesses, printed circuit board assemblies, motors, solenoids, actuators, sensors, switches. A lot of work in electric vehicle over the last 3 to 4 years, so a lot of teardowns and costing of components of electric motors, batteries, and all the systems required to run those components. So the cooling systems, the wire harnesses, the structures, control modules. We also do teardowns. If you purchase black box assemblies where you do not own the designs, we're very good at tearing those down and costing all the components along with sub-assemblies, final assembly, tooling, and product development cost. I want to very quickly just talk about the cost model types, what we recognize and what we focus on. So we do see these high-level rule of thumb cost models, typically a cost per pound, cost per kilogram, cost per inch, cost per square inch, square foot. Those are common. What's good about them is it's easy, it gets you in the ballpark, is good at identifying high flyers, but it also can be in its actual manufacturing processes. It will be regional specific globally and also within a particular country. It generally has minimal waste assumed, above average capacity, for a plant. So 2 shifts versus 1 shift. And we're generally going to have SG&A and profit set in that 15 to 20, could get as high as 25% range. So that generally gets us started. We can cost really any part using that. Eventually, if you find opportunity, which you likely will, you're going to have to work with your suppliers. And that's when we transition to our other 2 cost models. The second one is collaborative enterprise models, where we share that enterprise model with suppliers, and we start to get feedback and work with that supplier to customize to their rates, their equipment. Then we have a third one called our open book cost model. That is very popular. We win awards for this. The feedback and customer satisfaction, both the supplier and the supply chain management team, we get very good feedback. We like it because it's the fastest path to the most savings. It's the fastest path to getting an agreement with suppliers, and we just get very positive feedback. This is an example of a cost model that was built. This happens to be a casting cost model. It represents an automatic sand casting operation, and such as a Desomatic or a Cinto or a Hunter type of equipment. It was built together with the customer and the supplier, and we used an open book process. So now the customer or supply chain can actually cost on behalf of the supplier quickly and have confidence that the supplier will be able to meet the pricing that the tool generates. And I do want to say that the supply chain management team did a good job of filtering the higher cost suppliers, really focused on the suppliers that they thought were the most competitive, and that's where we developed the open book cost model. Each cost model is customized to every supplier and actually is customized to a particular factory and location. Our resources around the world. So we are headquartered here in Detroit, Michigan, and but we have cost engineering resources in Eastern Europe, Pune, India, and also Shanghai, China. The reason we have that is we need to support global supply chains, and many of our customers are also global, and they have operations around the world. Okay, we're going to talk about the basics of product costing. We just have a few slides. So our goal is to cost in the same manner that a manufacturer would cost. It's important for credibility. We want to be able to speak the same language as the manufacturer. So there's 5 major areas of cost with products: materials and components, processing, the direct labor, processing, the factory overhead, sometimes called burden, SG&A, selling, general and administrative, and profit. Let's go a little bit deeper. When you think about SG&A, typically it's going to be your sales and marketing resources. So that's going to be people and budgets. You're going to have your executives, finance and accounting. Legal will also be in there, generally a small cost, but and then purchasing, engineering, research and development, if the company has it. A lot of your suppliers are going to be make to print, so they won't really have that research and development, but they will have process engineering, tooling engineering. Some of that cost can be in the factory overheads. Sometimes it's in the SG&A, so that one can get moved around a little bit. When you think of material costs, it's not just raw materials. It's going to be your purchase components, outside services, inbound freight. There could be some storage and other overheads, and sometimes we have obsolescence cost for parts that are no longer used. When you think of overhead, that is the most complex part of the cost structure. It basically is the cost for all of your equipment, your management, your utilities, and indirect labor is is going to be part of that overhead. And then your last one is direct labor. It's not just the wages. You're going to typically have benefits also and taxes part of that. There's a basic formula that we use over and over. It can be applied really to any part of your life and is also applied to the costing of manufactured products. And that is cost equals a rate times a usage. This is an important formula because what we want to do is benchmark the rate and the usage. And we want to make sure that those are competitive because if they are, then you'll have a competitive cost. If you find that they're not competitive, that's where the waste identification happens. So when you think of rates, it's a cost per pound for steel, maybe a cost per piece for components. Labor, an example would be the cost per hour. Usage is going to be the pounds, the number of components, and the cycle time for that direct labor. Just a few more examples. So when you think of steel, we're going to have a cost per pound for that steel, and there'll be a usage per part. It's not going to necessarily be the net weight of the part. It's going to be a gross weight. In the when it comes to castings, we're going to have a pour weight, but we know that there'll be parts of that casting that will get trimmed and then remelted. So in those cases, we'll need to cost for the actual casting weight. Other examples is labor, again, and burden. Burden is interesting. We want to translate that into a cost per hour. Essentially, what you can, the way you can think about it is you are renting the plant management team and the direct labor, but you're more than just the plant management team. It's everything that it costs to run that facility. So as we listed earlier, utilities, property, taxes, rent, repairs and maintenance, etc. And then there's SG&A and profit, typically a percentage, and that's applied to manufacturing costs or the sell price. So by applying costs in this manner, we are now costing the same way that a manufacturer would cost, and that sets us up to have credibility so we can support effective negotiations. Okay, let's go through an actual example. We're going to look at a casting and machining. So the background on this is it's an aluminum high pressure die cast part, and plus machining. So the supplier is asking for a price increase from $67 today to $73. That's a 11% overall increase. May seem reasonable given our inflation rates, although we have also heard that parts are getting multiple increases over the last 18 months, and they're expected to continue to get some increases into the future. So the reason for the increase is raw material increase from $1.85 per pound to $2.12, and then also a labor increase from $24 per hour to $27 per hour. So the question that the customer wanted answered is, am I paying a fair price for my part? The second question is, I'm considering India as a source region. What would the cost be if I was to source from that region of the world? So the first thing that we do is we are going to map out the raw materials. In this case, we don't have any purchase components. There may be some outside services depending upon how vertically integrated the supplier is. So we typically work with the buyer to understand what is outsourced. Anytime you have outsourced services, and in this case, such as say impregnation or machining, there's going to be additional SG&As and there's going to be some additional freight costs. So if we know that, then we'll add that in. If we know that the company is vertically integrated, it's going to be more efficient, then we'll cost it in that manner. So for this particular part, this is the cost in the United States. And so what I've done is you'll see the three green check marks. We're going to deep dive those three costs. Certainly we could deep dive all of these, but for time purposes, we'll just focus on those three. So I picked the first one is the actual die casting process. The second is the impregnation. It's quite expensive at $8, almost $9. And then the machining process that is close to $20. So this is the quick summary. Going from left to right, we have the current price at 66, the price increase at 73. Our cost model for the United States is indicating that the with SG&A and profit at 20%, that the cost should be about $68. So it is showing an increase, but not to the full extent of the $73. And then if you were to go to India, there is a very significant savings that does include the freight and some additional packaging cost. So in this particular example, we would be able to reduce the increase to $2 per part instead of $7. It represents, in this case, about $20K in savings per year. This happens to be in production for multiple years. If we were to consider India, the savings are very significant. Of course, there are risks, and we understand today that those risks are even heightened and exaggerated today, even more. This is the quick 3-year impact for the USA and the India. So that is significant. It's important. We like to provide strong ROIs for our customers. Okay, this is the breakdown of costs. We're going to focus on the 3 items: high pressure die cast, in this case a 300-ton machine, the impregnation process, and then the machining process, which is actually four machining processes, and we'll highlight that in a few slides. Okay, so when we start to prepare the cost for aluminum high pressure die cast process, we first have to calculate what is the tonnage required and what is the cycle time. So we have calculators that do this. There's some fairly moderate levels of engineering required to calculate these. And in this case, we are showing a required tonnage of 239 tons. There's always a safety factor that you have to put in. It ranges in that 20% range. And so that would be 287 tons. And so we have to round up to the next available machine, which is typically a 300-ton machine. The cycle time calculator you'll see there at 35 seconds. I do want to say that we will, in addition, add a 20 to 30 and sometimes a little more, but a 20 to 30% efficiency factor on the cycle time also. Okay, and so now we'll actually perform the costing. And so for this operation, we, in the United States, we would assume a burden rate for this equipment at about $150 per hour. The labor rate at 27. You'll see one person running the machine. We do have a setup cost, and so that is significant because our volumes are lower for this particular customer. They produce every 2 weeks in order to reduce their inventory, and so there is a premium that you have to pay for that setup. At least you have visibility into it now, and you can manage that better. It is a form of waste. But you'll see the USA cost at $2.48 and India at $1.09. In India, you'll see the burden rate is about half, and the labor rate is an 80 to 90% reduction. The cycle times will typically be the same. That efficiency factor is assumed to be the same. Can be a little bit lower in India versus the US. Although I do have to say, visiting India, the better companies typically are going to achieve similar productivity levels as the United States. Okay, let's cost the second one. So this is impregnation. Impregnation is the process of using resin to help fill porosity in the part. And so this is actually quite expensive. If you look at why, it's that cycle time. The previous operation was 35 seconds. This one is 240 seconds, which is about 4 minutes. And so we have a labor rate of $27, a burden rate of 80. You will see that the operator is assumed at half an operator, and that's because the cycle time is so long. In India, the burden rate is going to be generally about half as in the United States, and again, that labor rate's quite low. So United States is $8.91, and India is projected to be at $3.93. Okay, we're going to hit the third of the focus manufacturing steps, and that's going to be machining. The machining process actually requires 4 different machining operations, and that's to be able to get access to the different surfaces on this particular part. So we have an op 10, 20, 30, and 40. When you think of machining, it is more complex. We have to recognize all of the cycle time drivers. So we've listed those here. So it's cutting speed, it's depth of cut, air time, that's where the tool is moving, the tool change time, and also the loading and the unloading of the part. And there's some additional time drivers when you think of setup, and we've listed those there also. We have developed a time predictor for machining, and this just highlights that. Okay, let's actually cost an operation. We're going to cost op 10. So again, our labor rate's at 27. It used to be 24. Our burden to run these machines typically is going to be about $60 an hour. In the United States, you can see we're at about 30, or we are at 30 in India. The cycle time to produce this is 232 seconds, but with the efficiency factor of 70%, so we're 30% inefficient, that is going to go to 331 seconds. And so the cost in the United States is $6.77. And in India, that cost is $2.88. Okay, so the result, the customer's feedback was very positive. They specifically recognized that we cost at the same level as the manufacturer. The particular purchasing director that was overseeing this pilot had run a factory before and understood what it took to be able to predict machining cycle time, which is the most challenging part of this costing project, and was very impressed that we were able to be extremely accurate. So that was very nice. The customer would like to implement that now across their entire commodity. So we are costing all of their high value castings and machining. And they have also added additional commodities such as wire harnesses, stampings, and fabrications. So we've assembled a team for the customer, and now we're kicking off additional costing events for the customer to help them manage their supply chain. Okay, let's talk about effective negotiations. We have a condensed version here for today's webinar. We do have a full webinar that dedicated to just negotiations, but today we'll have just a very condensed one. So step one is we do need to set the expectation that we are going to support the supplier's request to increase costs because of inflation. We have to. If you don't, then the relationship will be damaged, and eventually the supplier will either will probably stop shipping. So, but we do want to set the expectation that we will review all costs. And what you'll find is that when manufacturers come in for inflation requests, they only focus on the inflation. There have been, I guarantee, improvements that have been made on the plant floor with the operations, and a lot of times with the blank size of the raw material. And so we'll want to set the expectation that we will look at all costs. Step two, we always encourage to visit the supplier, do some relationship building, discuss hopefully growth if that's a part of your future. Do a plant tour. We do ask that buyer, while they're there, to gather some basic processing information, such as process flow, some cycle times, and number of operators, equipment also, and then set these expectations, reiterate these expectations during that visit. So we will then review, and we will cost, just like we've shown you here, we will cost the entire product. That is recommended to be provided in full detail to the manufacturer, and let them know that we are supporting them, that we accept their inflation increases, we recognize it as real, but we want to focus on the complete costing. What you'll find is as you start to move in this direction, the negotiation process will start to move away from a focus on cost and really on relationship. And so what we have found is you'll need to celebrate the relationship and the good things that the supplier has done for you, but you'll need to push it back onto the facts, the costing facts. These are typical strategies that we see out there in our negotiations. So we're doing negotiations every week, every month, literally tens, if not hundreds of them. So suppliers will play on your emotional and relationship history. They'll want to often focus on other parts of the relationship besides costs. They'll typically want to focus discussions on how the supplier has great quality and delivery service, engineering support. They will often cite multiple examples of saving the customer and how that is important, and they'll try to essentially tie that to a higher cost and a higher price. And so what's important is to recognize it, to celebrate it, but it really is not an additional cost. The costing that we would do would be complete and would be factual. And so the key is to push the discussion and the negotiation back onto what the facts of what costs are, and the results of accurate costs is going to be a price. As you conclude your negotiations, you may not close all the gaps. You may not close any of them. We'll talk more about that in some follow-up questions, but most of the time you will make some improvements. You may not get all of the savings. Life still is a negotiation, but you'll likely make some improvements. If there are gaps that are not fully closed, then we always recommend that you shift into what we call productivity improvements. If the part's going to be produced into the future, we would ask that the full savings or offset be implemented, or whatever portion of that offset is, over some period of time, if possible. We can also use these inflation offsets that may not have been fully negotiated to be addressed in future inflation. The manufacturer now knows that you'll be using this process, and they'll be much less likely to come in for additional inflation. And then also this costing work can be used as targets to develop. If you want to develop another supplier as an option, you'll be able to use these to set proper targets. Okay, we're going to quickly go through our free cost engineering offering, and then we'll take questions. So we do have a free trial. The goal of the trial is to show the power of how cost modeling knowledge can help proactively identify savings opportunities, and we'd like to help you understand the potential for your company. Our scope is we ask that you choose a commodity that is significant to your company, and because it's free, we ask that we keep the part count down and we choose more simple parts, not big assemblies. And then you can choose 2 regions of the world where we can cost and do those what ifs for you if you're interested. The process really takes about 2 weeks. We start off by putting in a mutual NDA in place. Typically, it's going to be your format, and we will then assign a cost engineering manager, and there'll be a team to support that manager. We'll have a launch meeting where we'll answer questions and start to collect that information from the customer. That information is going to be part specific. So drawing specifications, 3D models, your production volumes, and your current pricing and price increase if you have one. We'll perform the costing. We'll meet with your team. We'll review those results. We'll get feedback. We may have to make a few adjustments if everything's not correct in its assumptions. And then we'll finalize the costing, the results, and then do some interpretation on whether we think it's helpful and could make a positive impact to your company. So how to get started? You can contact me, Ed Pretzel. This is my email address, edpretzel@collaborativasupplychains.com. I'll schedule a short meeting with you to help understand your company and your products, answer your questions, maybe help you select a commodity to get started with. We'll then complete the NDA and we'll assign a cost engineering manager. I have offered my cell phone also. Okay, we'd like to take any questions.
Can we get a copy of this presentation?
Yes, you can. If you email me, I will send you a PDF of this. I've got just some common questions that are asked that I'll quickly go through. What happens if a supplier does not agree with some of the cost calculations and or assumptions? So this is a very, very good scenario. I would say if this is what's happening, you are on your path to success. It is normal to have some differences, but typically those differences are very minimal. You might have a 6, 7, 8, 10, 15% gap, and typically those differences are going to be 1 to 2%. But it does show that we're objective and